All right, 0 times infinity is not necessarily 0. It is indeterminate. Why? So I remember last summer when I was taking differential equations at college, this popped up a little bit. 0 times infinity, it happens to be indeterminate. What indeterminate kind of means is undefined, for instance, kind of like how 0 over 0 is undefined. It's also indeterminate. So this means that 0 over 0 could be 5, 1, 1,000, 10, -5. It could be anything, because anything makes sense. Because 0 over 0 equals x. Let's multiply both sides by 0. So 0x equals 0. Well, this is true no matter what x is. 0 times x. So we multiply both sides by 0. 0 times x is 0. That's true for most things. Unless x is infinity, which is what we're going to be talking about. Let me just erase this real quick. And this is my notes. These are the two proofs I have for infinity times 0 being indeterminate. That's what the ID means. The ID means indeterminate. So let me go ahead and erase all this. Okay, so let me put this on the end of my marker, the lid on the end. There we go. So first up we have 0 equaling 1 over infinity. Well, 0 can be 1 over infinity. 0 can be 2 over infinity. 0 can be 3 over infinity. You get the point. It could be anything. So if we have 0 times infinity, well, let's say we have 1 over infinity, which is what 0 is. So we're in place of this 0, we're putting this. In place of this 0, we're putting this, because 0 equals 1 over infinity. So we have 0 times infinity, so 1 over infinity times infinity. Well, this just becomes, these cancel. So you can just say 1. This can be done with any number. So that was just using this. What if we do this? So we have 2 over infinity, and we multiply it by infinity. Well, these cancel out. It equals 2. And we can do the same thing for 3 and so on. Any number, any finite number. So 0 times infinity, based on this argument, is indeterminate. It's some finite value. It can be 0, though. 0 is a valid answer, but it could also be any other finite number. Between not just positives, but it could also be negatives. Because 0 is neither positive or negative, you can have 0.0 repeating 1, so these zeros go on forever, or we can have negative 0.01 repeating, where the 0 repeats. These are both equal to 0. All right, let's do the next one. Whoops, that fell on the floor. All right, let's do the next proof, which is this, which involves this that I just wrote down. So we're going to take a little bit of a detour real quick to explain that. Let's say x equals 0.9 repeating, where the 9s go on forever. Well, 10x equals 9.9 forever repeating. Well, let's subtract x from 10x. So 9x equals 9.9 repeating minus 0.9 repeating. Well, 9x will equal 9, because the 0.9 repeating is infinite 9s, 0.9 repeating infinite 9s, they cancel each other out. So we just get 9x equals 9, which means x equals 1, and up here 0.9 repeating and 1, 0.9, hold on, let me write that a little bit further down. 0.9 repeating equals 1. So now that that's out of the way, let's just keep that there. Now that that's out of the way, we can get to talking about this. So we have 0.0 repeating 1. So if this is 10 and this is 10, 10 minus 10 is 0. Let's actually write this out. So let's do ones. Yeah, let's do ones. 1 minus 0.9 repeating equals 0 because 0.9 repeating equals 1, and 1 minus 1 is 0. So this is true. But at the same time, 1 minus 0.9 repeating equals 0.0 repeating with a 1 at the end. And if we have this 1 at the end after an infinite number of zeros, this is 1 over infinity. So let's go back to the original question. 0 times infinity. We have 0 here, which can be in place of that. We're going to have 0.0 repeating 1 times infinity, which equals any finite number. So this includes irrational numbers. It can include 0, negative numbers, positive numbers, any finite number, because 0 times infinity is indeterminate. It could be anything depending on the specific problem. All right, bye. Check out my paper review on Couperin octotheism on my YouTube channel. It is 7 hours and 11.5 minutes long.